Hi everyone, and welcome back to PT Dex Education. In this session of tutorials, we are going to be answering question 5, Part B and Part C of June 2023 Chemistry Advanced Level. So the B part says that an organic compound with molecular formula C4H9O2N has both the amino and the carboxylic acid functional groups and is optically active. A. Roman 1. What is a functional group? Simply, a functional group is an atom, a group of atoms, or a bond common to a homologous series, and that determines the chemical properties of all members of that series. A functional group again is an atom, a group of atoms, or a bond common to all members of a homologous series, and that determines the chemical properties of that homologous series. Roman 2 says, give the condition for the compound to be optically active. A compound is optically active if it contains an asymmetrical or a chiral carbon atom. So simply, the condition for optical activity is that the compound must contain a chiral carbon. Right. A chiral carbon atom is a carbon atom that has 4 different groups around it. For example, we can write CH3, CHOH, CH2, CH3. So here we have the formula for butanol. Right. So notice here that we have 1 group, 2 groups, 3 groups, and 4 groups. All the 4 groups are different. So butanol is an example of an optically active compound. Now, next question says, give the optical isomers of the compound. Let's give the optical isomers. Before that, we must write the structure of the compound. The compound contains the amino group. Amino group is NH2. Carboxylic acid group is COOH. So let's write the structure of the compound. We are going to have, these 2 groups are already present, right? So C4H9O2N can be broken into 3 parts. The first part is the amino part, next the carboxylic part, and the last part, carbon. Here we have 1 carbon, so we are left with 3 carbon. Hydrogen, we have 3 hydrogen, so we are left with 6 hydrogen to make 9. We have 2 oxygen, so no oxygen again, and the nitrogen is already there. So the structural formula is a combination of these 3 structures. So we are going to conclude by saying we have CH3, and we write this one in expanded form, CH3, CH2, here we have C2H5. We need H6. So that will give us CH. Then at the top we have the amino group and the carboxylic group. So the compound at the end we have CH3, CH2, then COOH, NH2, and H. So that is the structure of the compound, and this is the asymmetric carbon atom. The structure for the optical isomers, we draw them out. NH2, here we have COOH, here C2H5, and here hydrogen. The middle line, on the other side we have C, hydrogen, here HOOC, then here we have C2H5 and we have H2N. So those are the structures for the optical isomers of the compound. So guys, that brings us to the end of this first session where we look just at the B part. In our next lesson, we are going to discuss the C part of the question. We invite you to kindly subscribe and like the video and equally share with your friends. So see you in a short while for the C part.